Hey there! The May 4th SAT exam is rapidly approaching. If you haven't registered yet, the last date is 19th of April. So head right to the College Board website and register. Alright, so it's time to kick your prep into high gear. Today I've got something really special lined up for you. I'll be walking through a really hard SAT math problem. So stick around because by the end of this video, you will have the tools to tackle any geometry curveball that SAT throws your way. I am Shwetang. I scored a 1550 on the digital SAT and a perfect 800 on the SAT math section. So let's dive right in. Alright, so this is a hard geometry problem. This is sourced from the old Khan Academy paper SAT practice. It may not be there anymore. So let's look at this problem. So we see a safety cone, the ones that you would see placed on roads. Now, if you see, there is a right angle right here. Okay, so most likely this problem is going to test something on the right angles. Now, it says the figure gives the dimension in inches of a typical safety cone. What is the length of the slant height S in inches? Now, what we know is this is 12 inch, this is 28 inch, this is 2 inches, and we need to find out S. We don't see a right angle triangle anywhere. But can we just imagine and construct one? So it would look something like this. Let's draw a straight line here and a perpendicular line here. So this is my 90 degrees. Excuse my drawing. And let's draw a line right here. So if we were to extend it, it would have looked something like this. Okay. Basically, we are drawing the same thing here. And there is a line here also. And this is also 90 degrees, right? So we have two right angle triangles. Now what's interesting is between this smaller triangle and this larger triangle, we have 90 degrees same and we have one angle same, right? This angle is in the smaller triangle as well as in the larger triangle. So these two triangles are similar. If you notice, this third angle is also the same because these two lines are parallel, given that they both form 90 degree to this line. So these two angles are also the same, but even if we didn't know that, if two angles are congruent, then those two triangles are similar. With this, what we know is, let's give them some names, A, B, C, D, and E. We can write proportions for the side lengths. So using the similar angle triangle properties, this line, because it's opposite of this, okay, would be and the ratio of this line on the larger triangle would be the same as the ratio of sides opposite other angles. So let's try writing them out. So what is this length? This is 12, and because it's bifurcating it, it's a perpendicular bisector. This length is 6. Similarly, this total length is 2 inches, so this length is just 1 inch, right? The rest of it would be 1 inch, but we don't concern ourselves with that. This length is 28 inches. This is S. What we don't know are these two, but at some point we may need to calculate it. So let's name them X and Y. Okay. So we don't know X, we don't know Y, we don't know S, and S is what we need to find. So we will need a bunch of equations. Let's go back to that point. So let's say side lines opposite this angle is X here. It's X plus 28 here. So X by X plus 28 will be the same as opposite this angle is 1 in the smaller triangle and 6 in the larger triangle, so 1 by 6, and it will be the same as if you look at the 90 degree angle, y in the smaller triangle and y plus s is the hypotenuse for the larger triangle. Okay, so we have these proportions. Now it's very easy to calculate x, so let's do that. So x by x plus 28 equals 1 by 6. So let's multiply 6 with x. So 6x, and let's take this on the right hand side. 6x equals x plus 28. So we know that 5x equals 28 and x equals 5.6. Okay, so we know x. Now similarly, can we get something in y and y plus x? So y by y plus s equals 1 by 6. So let's again multiply this. 6y equals y plus s, or s equals 5y. Okay, so if we can calculate y, we already know x. S is fairly straightforward, it's just 5 times y. So what other properties do we need to know? So if you ever see right angle triangle, there are mostly just two concepts that are tested. One is special right angle triangle, so you would see something like a 30 degrees, 60 degrees, 45 degrees, but we don't see that here. The only other concept that would be tested is most likely going to be the Pythagorean theorem. So look here, this is just a reminder of what Pythagorean theorem is. If you have two smaller sides A and B and the hypotenuse C, the lengths can be put in a relation like this: C square equals A square plus B square. Now let's apply this in this smaller triangle. Let me just draw it again. So this smaller triangle is a right angle triangle. This is x, this is y, this is 1. If we were to rewrite it in this form, y square equals x square plus 1. Okay, we already know x. Let's put that back in. So y square equals 5.6 square, x is 5.6 plus 1. Okay, we may need to bring up the calculator here, so let's do that. Okay, so y square equals 5.6 whole square. So 5.6 whole square plus 1, that's 32.36. But y would be square root of this. So let's take a square root of this, which gives us 5.688. Okay, so y is 5.688. Now s is just 5 times y, right? So 5 times 5.688. Let's bring back the calculator. So 5 times 5.688, which is 28.44. So now I know that s is 28.44. Let's just go back. This is a grid in answer, so always see what needs to be gridded in. Round your answer to the nearest tenth of an inch. So we don't need this one. So this gets rounded off to s equals 28.4 inches. Okay. So just a quick recap. Whenever you see something which has a right angle, think of what concepts are being tested. If you see something like, if an angle is given and it's either 30, 45 or 60, you are being tested on the special right triangles. But if that's not given, more likely than not, you're being tested on the Pythagorean theorem. And obviously we also needed to know the similar triangle properties using which we made this, right? The side lengths are going to be in proportion if two triangles are similar triangles, right? This question, something like this, where there is a larger triangle and a smaller triangle inside it, and this is 90 degree. These questions have appeared quite often on the SAT. Usually this would be considered a harder problem. So now that you know this, it should be really easy when you get this on the SAT exam. Hope you found this video useful. Don't forget to like and subscribe for more such SAT tips and test taking strategies. Remember, once you master the concepts, you can solve anything. Best of luck on your SAT journey, and I'll see you in the next video.